In February 2025, scientists detected an asteroid heading our way. If it hit, it would create a crater the size of Manhattan and unleash a shockwave strong enough to flatten everything within 30 miles. Uh-oh, I'm out of here. Well, luckily for now, we're in the clear. But the threat is coming back in 2028, and this time, everything might change. You see, in 2025, NASA announced that an asteroid, called 2024 YR4, had a 3.1% chance of hitting Earth in 2032. Now, in asteroid terms, that's high enough to sound the alarm. The asteroid itself is not the end of the dinosaurs level, but it's big enough to level a city. The rock is about 130 to 300 feet wide. That's roughly the size of a large jet. Now, if something that size slammed into a populated area, it wouldn't end the world, but it would result in a very, very bad day. And still, no one panicked, and scientists weren't scrambling for bunkers. Because when we first spot an asteroid, we have to work with limited information. It's like seeing a plane high up in the sky and trying to guess exactly which gate it'll park at. That's why astronomers rush to gather more data. The asteroid itself seemed pretty ordinary. It was rocky, not some rare metal thing. It was first spotted in late 2024 by an observatory in Chile during a regular skyscan routine. There's this group called the International Asteroid Warning Network. Their job is to keep an eye on space rocks that might try to ruin your day. And back on January 29, 2025, they announced that the chances of that particular asteroid hitting Earth had gone over 1%. Now, 1% might not sound like much, but that's enough to make scientists start worrying. The impact risk for 2024 YR4 reached its highest point on February 18, 2025. That's when scientists calculated a 3.1% chance it could hit Earth. But by February 23, after more observations came in, that possibility was essentially ruled out completely. The asteroid's Torino scale rating, which is used to categorize the impact risk of near-Earth objects like asteroids and comets within the next 100 years, was lowered to 0. It means it's no longer considered a threat to Earth, well, for now. But scientists still keep tracking it, and based on additional data, there is now a 4% chance it could hit the Moon instead. If that were to happen, it would be on December 22, 2032. Right now, the asteroid is expected to pass about 5,600 miles from the Moon's surface. However, there's a very large uncertainty range, about plus or minus 46,000 miles. So it could easily miss the Moon by a very large distance. The last time we had something this dangerous was back in 2004, with an asteroid called 99942 Apophis. Back then, it had a 2.7 chance of hitting Earth in 2029. People were sweating. But after better observations, scientists ruled out the impact. This time we actually passed that old record. 2024 YR4 is currently heading out toward Jupiter's neighborhood and won't swing back close to us until 2028. And that's when everything might change. If the risk jumps above 10%, the IAWN will send out a formal warning to the United Nations. They'll tell countries in possible impact zones to maybe start preparing, because if we talk about the damage… Admittedly, this asteroid is not the 6-mile-wide monster that wiped out the dinosaurs 66 million years ago after hitting Earth. This here asteroid is in the city killer category. It sounds dramatic because it is, but it's not some global extinction stuff. The real problem isn't just its size, it's its speed. If the asteroid hits, it could be moving nearly 40,000 miles per hour. That's like flying from New York to LA in under 5 minutes. But still, the most likely scenario would be the asteroid exploding in the air before even hitting the ground. That's called an airburst. But if the asteroid is on the bigger end of the size estimates, it could actually reach the surface of our planet, slam into the ground, and make a crater. So that possibility's still on the table. As for where it could hit, the possible impact zone covers a huge area: Eastern Pacific, Northern South America, the Atlantic, Africa, the Arabian Peninsula, and South Asia. Raise your hand if we left you out. Keep in mind, though, that it's way too early to make life decisions based on that. So, no packing up and moving yet. Besides, we're not sitting here helpless. In 2022, NASA pulled off the DART mission, where they literally smashed a spacecraft into an asteroid to nudge it off course. And it worked. DART stands for Double Asteroid Redirection Test. It was built for NASA's Planetary Defense Office. They wanted to know if we could push an asteroid just enough for it to miss our planet. So they launched a spacecraft in November 2022, and it traveled through space for about 10 months. The plan from day one was to crash it. The target was a small asteroid moon called Dimorphos, which is about 530 feet across, the size of a large stadium. Dimorphos orbits a bigger asteroid called Didymos. The two of them just circle each other out there in space. What's important is that neither of them was threatening Earth, so this was a safe test. Now, DART was basically a heavy spacecraft with a camera and a smart guidance system. The strategy was to hit Dimorphos at about 14,000 miles per hour and let the force of that impact slightly change its orbit. In the final stretch, the spacecraft guided itself. It had to figure out which rock was which, lock onto the smaller one, and adjust its path without anyone steering it in real time. When it hit, the onboard camera sent back close-up images right up until the moment of impact. Then the signal stopped because the spacecraft had done its job and smashed into the asteroid. There was also a small Italian CubeSat that separated earlier and stayed back to photograph the collision and the resulting debris cloud. Those images showed a huge plume of rock and dust blasting out into space. Well, after that, astronomers around the world started measuring the orbit of Dimorphos very carefully. Before the collision, it took 11 hours and 55 minutes to circle Didymos. After the impact, it took 11 hours and 23 minutes. That's an impressive 32-minute difference. The interesting part was that the spacecraft alone wasn't responsible for all of that shift. When DART struck the surface, it threw tons of rocky material outward. All that rock and dust blasting off gave the asteroid an extra push, stronger than the spacecraft alone could have done. Scientists later realized that Dimorphos wasn't a solid chunk of rock. It was more like a loose pile of rubble held together by gravity. That probably helped produce more debris and a bigger push. So if we ever face a denser, more solid asteroid, the same technique might not have the same exact effect. That's why scientists are also looking at other ideas, like using lasers to heat up part of the asteroid so bits of rock fly off and slowly push it in the opposite direction, like giving it a tiny built-in rocket. Or they could place a spacecraft close to the asteroid and use its gravity to slowly pull it off course, like a small tugboat guiding a huge ship. Or if things got really serious, use a nuclear blast as a last resort shove. Despite the success of the DART mission, NASA says we do not have a ready, reliable system that could stop a city-killing asteroid if one suddenly shows up on a collision course with Earth. The danger isn't the giant dinosaur-level asteroids. Those are huge and easy to track. Neither is it tiny rocks that burn up in the atmosphere all the time. It's the middle-sized ones, around 500 feet wide. Scientists estimate there are about 25,000 near-Earth objects in that size range moving near Earth's orbit. So far, we've only found about 40% of them. That means most of them are still out there, and we don't know exactly where they are. The problem is they're dark. Most don't reflect much sunlight, so even powerful telescopes can miss them. To help fix that, NASA plans to launch a new space telescope called the Near-Earth Object Surveyor. Instead of looking for sunlight bouncing off asteroids, it'll look for heat. Even a dark asteroid absorbs sunlight and gives off heat, and that's easier to see in infrared. If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it is, it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yarkovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare. Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid. All because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only two 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system. So, we just spotted an asteroid so massive it could wipe out an entire continent if it ever hit Earth. And it's moving insanely fast, almost record speed. But what makes it really scary is how it's basically playing hide-and-seek with us. It can slip right into the sun's glare and vanish completely. And yeah, it just did it again. It disappeared. So, when we finally spot it again, will we have enough time to prepare? Or could it already be too late for humanity? Yeah. Do I have your attention now? Thanks. So, meet 2025 SC79. That's a mouthful, so I'll just nickname it Scooby. This newly found asteroid is a sneaky one, the kind that loves hiding in the sun's glare. Think of it as trying to spot a firefly next to a stadium light. The brightness hits your eyes and outshines anything faint nearby. So yeah, you won't see that firefly. Now asteroids hide in the same frustrating way. When they end up close to the sun from our point of view on Earth, the glare overwhelms our telescopes, and the asteroid's dim, reflected light gets lost in it. That's why some asteroids can cruise along in the sun's direction and stay basically invisible to us. And scientists say the most dangerous asteroids, the ones that could wipe out a whole city, are the hardest to detect. That's why astronomers need to somehow dodge the sun's glare. One way they do it is by observing the sky during the short window of twilight. Right before sunrise or just after sunset. And that timing is a big deal, because it's the only way to catch some risky asteroid before it sneaks up on Earth. Scientists say that if one of these so-called twilight asteroids ever gets close to Earth, it could be a serious impact threat. And it was during one of these twilight observing sessions that scientists finally spotted this huge asteroid. It was September 27, 2025. Scott Shepard, an astronomer at a Washington-based institute, was scanning the sky, hunting for anything unusual in our solar system. And he had an incredible tool in his hands, the Dark Energy Camera, or DECAM, one of the most powerful sky survey cameras on Earth, built to spot faint objects across huge areas of the universe. At one point, he spotted a faint dot moving across the image. So he quickly aimed the high-tech camera at it, and things got more interesting. Its movement matched what astronomers expect from asteroids that orbit very close to the sun. Then, follow-up observations with the Gemini and Magellan telescopes confirm the discovery. Yes, this really was an asteroid, and there are two particularly curious things about it. First, it's fast, like really fast. In fact, it is the second fastest known asteroid orbit in the solar system. It loops around the Sun once every 128 days. For comparison, Mercury, the closest planet to the Sun, takes 88 days to go around once. Second, its orbit is super rare. This is only the second known object that stays completely inside Venus's orbit. That also puts it in one of the rarest asteroid groups out there, the Asteroids. These are asteroids whose orbits sit entirely inside Earth's orbit. Astronomers have found only a few of them so far, and Scooby is the 39th one in the list. The team of scientists also figured out that this asteroid is pretty big, measuring about 2,300 feet across. That's roughly the size of Merdeka 118, the second tallest building on Earth. If an asteroid this size ever slammed into Earth, it wouldn't just be bad, it would be catastrophic. We're talking about damage on a continental scale. It would blast a huge crater into the ground, then throw out a shockwave powerful enough to wipe out forests and wreck cities. Seismic waves would ripple through the crust, triggering widespread earthquakes around magnitude 7.4, and people could still feel them about 300 miles away from the strike. And that's not all. A brutal air pressure blast would race outward, shattering windows more than 1,000 miles away. Then comes the aftermath. Dust and debris from the impact could shoot up into the atmosphere, block some sunlight, and mess with our climate. I know, you might feel scared right now, but don't worry about it. Thankfully, Scooby isn't going to do anything like that, because it's not on a collision course with Earth. Right now, the math shows it won't be making any close passes by our planet, at least not anytime soon. Still, there's a lot more to learn about this asteroid, but any further studies will have to wait. For now, it has disappeared behind the Sun and is out of sight. Once it reappears, astronomers will take a closer look and try to learn more about what it's made of. That part really matters, because this asteroid is somehow holding up while orbiting so close to the Sun's brutal heat. You see, this asteroid gets very near to the Sun. At its closest point, this asteroid is blasted with almost 6 times Earth's sunlight. At that distance, its surface could heat up to about 440 degrees Fahrenheit. What scientists don't know yet is how a rock this big can get baked over and over again without falling apart. And there are 2 more things astronomers want to check once it comes back into view: how fast it spins and how bright it looks. Now, by bright, I mean how much sunlight it reflects, because asteroids don't make their own sunlight. They're just big rocky chunks that shine by reflecting sunlight back at us. Anyway, those clues can tell scientists what Scooby is made of. One possibility is that this asteroid is loaded with dense metal, and that could explain how it survives the Sun's brutal heat. And if that turns out to be true, this asteroid could be a relic from when the solar system was just forming. Or maybe it slowly moved closer to the Sun because the gravity of Venus and Mercury gently pulled on it again and again over millions of years. Now, even though SE79 isn't a real danger to us, and there's still a lot we don't know about it, just finding it is already a big deal. It's a reminder that big asteroids can hide from us. So even in our own cosmic backyard, there are still blind spots where large objects can stay hidden until the right moment of twilight gives them away. And as our detection tech gets better, we keep finding more and more asteroids. By now, scientists have spotted over 1 million in the solar system. They come in all sizes, from monsters like Vesta that measure about 329 miles wide, all the way down to rocks that are smaller than a house. Now, out of all the asteroids we know, about 40,000 are what we call near-Earth asteroids, or NEAs. That just means their orbits bring them close to our neighborhood. Technically, their closest point to the Sun is less than 1.3 times the Earth-Sun distance. It's close enough for planetary defense systems to keep a careful eye on them. And that's exactly why we can relax. I mean, nobody has to lose sleep imagining an asteroid slamming into our planet. Every time scientists discover a new asteroid that comes anywhere near Earth, they track it and run the numbers right away. And then they map out its path years, decades, or even centuries into the future. And they don't do it by guesswork. NASA's automated systems, like Sentry, constantly scan the asteroid catalog and calculate whether any of these objects has even a small chance of hitting Earth over the next 100 years. If something looks risky, it jumps to the top of the watch list and gets followed up fast. So yeah, there are almost 2,000 near-Earth asteroids that technically have some chance of hitting us in the next 100 years. But don't panic. Most are small and harmless, hey, like me. And their odds of impact are usually way under 1%. See why I said we shouldn't stress too much? Cool. Now, sleep tight. Asteroids, unseen but perilous, are traveling in the same orbit as Venus, and our telescopes just can't detect them. The threat is real. If one of these objects heads toward Earth, we're all doomed. Well, maybe. In that not-so-distant, relatively of course, stretch of space where Venus orbits, there may be hundreds of asteroids we've never detected. They could be circling the Sun right at this moment, but they stay completely hidden from us. The problem is their position. Because they're closer to the Sun than Earth is, we can only look for them by pointing our telescopes almost straight toward the Sun. Any sunlight they reflect gets swallowed up by the Sun's brightness, so they basically disappear in the glare. These objects aren't part of the main asteroid belt between Mars and Jupiter. They're much closer, moving through the inner solar system. They travel in what's called a 1-to-1 resonance with Venus. It means they orbit the Sun in almost the exact same period as the planet. This makes them Venusian co-orbital asteroids, rocks that orbit the Sun in the same area as Venus instead of having their own separate path. Now, researchers use computer modeling and long-term simulations to figure out how these hidden asteroids behave and whether they could ever threaten Earth. The results aren't reassuring. The orbits of these asteroids aren't stable, their paths shift over time, and about every 12,000 years, their whole orbital setup can change. An asteroid that stays close to Venus for thousands of years can eventually drift away from it and come much closer to Earth's orbit. Now, Jupiter has its own group of co-orbital asteroids called Trojans, but those are much more stable, and the planet is so far from us that even unstable ones wouldn't be a problem. The Venus co-orbitals are different. They're close, and their orbits can change enough that some of them may eventually cross Earth's path. So even though these asteroids are invisible to us right now, the models suggest that some of them could one day get close enough to pose a real risk to our planet, even if that risk is thousands of years away. Now, even worse, scientists think that the small number of Venus co-orbital asteroids we've already discovered is only a tiny sample of what's actually out there. They suspect that most of this population is still completely unseen. Some of these hidden objects may be almost 1,000 feet wide. Such an asteroid is large enough to create a crater about 2 to 3 miles across if it ever hits Earth. Oh boy. An impact of that size would release energy equal to hundreds of megatons, causing massive destruction if it happened in a densely populated region. An asteroid would slam into the planet with enormous force, turning solid rock into vapor. Everything, and everyone close enough to see the crash, wouldn't live long. The ground around the impact crater would be covered with hot ash, grit, and rubble. Grass, trees, and shrubbery around the crash site would burst into flames. But that's not the worst thing. The impact would trigger a series of natural disasters, such as tsunamis and earthquakes, depending on the region. The sky would get almost completely black because of all that ash in the air. It would block the sunlight. Rainwater would get highly acidic. Fires would keep raging. They would produce enough toxins, harming the ozone layer. Earth's shield against the sun's radiation and heat would weaken. Even though humans would probably survive, the quality of life would plummet, and no one knows how long it'd last. So far, the Venus co-orbital asteroids we have found all share one thing. They follow stretched-out orbits. Their eccentricity is higher than 0.38. Eccentricity is just a measure of how round an orbit is. A value of 0 means a perfect circle. Earth's orbit is 0.017, which is almost a circle. The higher the number, the more oval the orbit becomes. And since these known asteroids follow a long, stretched path, they can drift far from Venus and swing closer to Earth. When that happens, we can sometimes spot them during twilight, when the sun is below the horizon but still bright enough to light up small nearby objects. Scientists wanted to understand the asteroids we couldn't see yet, especially the ones with more circular orbits. They ran simulations to study how those lower eccentricity asteroids might move, whether any of them could threaten Earth in the near future, and whether the new Vera Rubin Observatory, with the biggest astronomy camera ever built, would be able to spot them. The results showed something worrying. Even some low eccentricity orbits could bring long-term risk to Earth. Even worse, the Rubin Observatory will only be able to see these objects during short windows at certain times of the year. That means many of them could still slip by unnoticed. Now this creates a real problem for planetary defense. It's hard to prepare for the danger if you can't see it coming. One way to fix this blind spot would be to place a space observatory near Venus, or even in the same orbit as Venus, so it can watch that region directly. NASA's upcoming NEO Surveyor mission might also help by studying the inner solar system, where these objects hide. In the end, scientists think ground-based surveys like the Rubin Observatory will catch some of these asteroids, but not all. To map the full population of Venus co-orbitals, we'll need a dedicated space mission close to Venus. Right now, astronomers have identified only 20 Venus co-orbital asteroids. All but one have an eccentricity higher than 0.38. These stretched-out orbits carry them farther from the Sun, where telescopes on Earth have a fighting chance to spot them. But there should be many more asteroids with more circular paths that stay closer to the Sun's glare. So, what if we spotted a visitor from Venus when it was already approaching Earth? What would we do? Well, we could launch a bunch of nuclear explosives at the asteroid. If we could just blow it to pieces while it was still far away, the debris would scatter safely into space instead of causing problems near Earth. On the other hand, what if the explosion accidentally changed the asteroid's path and sent some fragments toward Earth? It's a real possibility. Or we could gently nudge it off its course toward Earth. But it would only work if we knew exactly the weight of the asteroid. Without knowing its mass, space agencies wouldn't be able to design a precise mission to knock it off course. In theory, they could send out a reconnaissance spacecraft first, something to get close to the asteroid, measure it, and figure out the best way to push it away. But what if we didn't have enough time for that? By the time we collected all the needed data and built the right hardware, it'd be too late to intercept the asteroid. By the way, NASA actually has some experience with asteroid defense. Back in 2022, they pulled off something groundbreaking with their Double Asteroid Redirection Test, or DART. That mission was all about proving that humans could physically change an asteroid's path without using explosives. NASA launched a small spacecraft in November 2021, and after almost a year of travel, it crashed head-on into a tiny asteroid named Dimorphos at about 14,000 miles per hour. The idea was simple. If you hit an asteroid hard enough, you can slightly change its orbit, just enough to make it miss Earth someday. And it actually worked. The test showed that even a relatively small spacecraft could make a major difference. Now, the European Space Agency wants to double-check exactly how much of an effect that crash had. In October 2024, they launched a follow-up spacecraft called Hera from Florida's Cape Canaveral Space Force Station. Hera's on a 2-year journey to reach Dimorphos and its bigger partner asteroid Didymos. By October 2026, Hera will enter orbit around the asteroid pair and start collecting data, basically checking NASA's math. ESA scientists hope that once they analyze the impact site, they'll find out how effective DART was at changing the asteroid's trajectory. In any case, planetary defense has to think about more ways to protect the planet from wayward asteroids. It also has to take seriously the things we still can't see. So, how do you feel about cooking? Nah, pasta and burgers are overrated. How about something more exotic, or rather, more cosmic? So, the recipe is simple. Take a team of enthusiastic astronomers and add some old images from the James Webb Space Telescope. Stir really well, and you'll get a shocking number of tiny asteroids in the asteroid belt between Mars and Jupiter. Yummy! The highlight of this dish is the direction in which some of the asteroids are moving, because in their way, there's our poor planet. Are we doomed just because you decided to cook? Now, the asteroids I'm talking about are much smaller than the massive space rock that wiped out the dinosaurs, but they can still cause considerable damage. They range in size from as small as a bus to as big as a stadium. But even those small ones pack quite a punch. Let's look at a recent dramatic example. It happened on February 15, 2013. A small asteroid just tens of feet wide exploded in an airburst over Chelyabinsk in Siberia, releasing an insane amount of energy. Many people witnessed and recorded the event, and it gave scientists vital clues. New computer models helped scientists reconstruct the size, speed, and impact of the Chelyabinsk meteor. It was likely an asteroid, about the size of a 5-story building, exploding from 15 to 18 miles above Earth's surface with an enormous, incomparable force. The blast shattered 1 million windows and hurt over 1,000 people. Fortunately, it wasn't powerful enough to cause too much damage, but it gave us an idea about how dangerous an airburst can be. Now, an airburst occurs when an object explodes high in the atmosphere, never striking the ground, but releasing enough energy to devastate the area. But back to the small asteroids. The most dangerous thing about them is that they hit the Earth far more often than the larger ones, about 10,000 times more frequently. To make matters worse, their small size makes them harder to detect in advance, leaving little time for preparation if one is heading towards Earth. Now, let's travel back in time. Uh-oh, dinosaurs, too far back. Ah, there we go. A team of astronomers is working on a special method to find small asteroids in telescope images that were originally taken to study distant stars. Using this method, they've looked through thousands of JWST images of a star system called TRAPPIST-1. It's located 40 light-years away and is one of the most studied systems outside our solar system. Now, while analyzing these images, they discovered 138 new asteroids in the main asteroid belt, plus 8 they already knew about. And guess what? Among the newly found asteroids, 6 seem to have been pushed into paths that could bring them closer to Earth. Who did it? Well, probably nearby planets. Are they holding a grudge against Earth? Interestingly, scientists thought they'd find just a few new asteroids, but the number was much higher than they expected. Yet, it's no wonder. Right now, they're exploring a part of space they didn't know much about before. Now, let's talk about the hero of the day, the James Webb Space Telescope. It's especially good at finding small asteroids because it can detect their heat. These asteroids give off infrared radiation, which is much easier to see than the faint sunlight that reflects off their surfaces. This technology allowed scientists to spot the smallest asteroids ever seen in the main asteroid belt. The asteroids they found are pieces left over from collisions between bigger space rocks. Finding them helps astronomers understand the history of the asteroid belt and improve methods for tracking small asteroids that could threaten Earth. The researchers are planning to use James Webb to observe other star systems for at least 500 hours. They expect this work to uncover thousands more small asteroids in the solar system. Other advanced telescopes, like the Vera C. Rubin Observatory in Chile, will also help. Starting in 2025, this observatory will use the world's largest digital camera to photograph the southern sky every night for at least 10 years. Each image will cover a huge area of the sky, about 40 times the size of the full moon. The observatory might find up to 2.5 million asteroids in just 6 months, almost doubling the number we know about. Recently, NASA has identified 2 small asteroids. They were supposed to pass near Earth on December 16, 2024. Luckily, neither posed any danger to our planet. The first asteroid was 71 feet wide, about the size of a large airplane, and was traveling at 10,800 miles per hour. The second asteroid was slightly smaller, 56 feet wide, but it traveled faster at 14,700 miles per hour. But hey, even though this time the danger is past, who knows what the future will bring? It may sound weird these days, but astronomers didn't really care much about small asteroids for a rather long time. They thought of them as just random space debris that got in the way of observing stars. Some even called them sky parasites. But now, the way we see these little space rocks has completely changed. You see, until recently, we could only spot really big asteroids, those over a mile wide. The smaller ones just blended into the background noise in telescope images. But then, a clever trick appeared where multiple images of the same part of the sky were combined, making those faint small objects finally stand out. The data from certain telescopes, along with the James Webb Space Telescope, helps us improve planetary defense. But there's more to it than just protecting our planet. Studying these small asteroids also teaches us about how the solar system evolved. There are so many of them because they're fragments from collisions between bigger space rocks. One researcher has said this is like looking at old data in a new way. These small asteroids, which people used to think of as space junk, are crucial for understanding our solar system and even preparing for whatever the future holds. Among those hundreds of millions of rocks orbiting the Sun in the asteroid belt between Mars and Jupiter, some are especially worrisome. They come close enough to Earth for it to be quite concerning. NASA classifies asteroids that orbit within 30 million miles of our planet as near-Earth objects, and those could pose a serious threat if they were to collide with our planet. Right now, NASA is closely monitoring an asteroid named Bennu. This is a fairly large space rock, measuring about 1,600 feet across. It could, potentially, crash into Earth in 159 years. First, the astronauts spotted it in 1999. So currently, experts believe that there's a small chance Bennu could drift into Earth's orbit and collide with our planet by September 24, 2182. Would it be bad? Well, to put it in perspective, Bennu is taller than the Empire State Building. If it hit Earth, it would generate 1,200 megatons of energy, an amount so massive that nothing on Earth could generate that. NASA scientists are particularly concerned about a tiny chance that Bennu could pass through a gravitational keyhole during a flyby in the 22nd century. This keyhole is a region in space that could set the asteroid on a path that brings it directly to Earth. Now, Bennu flies by Earth every 6 years and has had 3 close encounters with us in 1999, 2005, and 2011. Right now, scientists estimate that the chance of Bennu hitting Earth by 2182 is about 1 in 2,700, more than 5 times greater than the chance of being struck by lightning. Although the chances of Bennu colliding with Earth are very low right now, this space rock is still classified as a potentially hazardous asteroid because it might come as close as 4.65 million miles to Earth. Now, this asteroid is another space rock that we need to keep an eye on. It's a near-Earth object about 1,100 feet across, and it was discovered in 2004. Initially, it was considered one of the most dangerous asteroids ever detected. Apophis quickly gained attention because experts believed it could pose a serious threat to Earth because of its close approach to our planet in 2029. However, after further study of its orbit, astronomers determined that there was no risk of a collision for at least a century. Well, we can all breathe easier now, can't we? Astronomers just spotted an asteroid roughly the size of 8 football fields. It spins so fast, that it completes a full rotation in just under 2 minutes, which makes it the fastest asteroid ever found in its size class. If this bad boy hits Earth, the consequences will be, well, let's just say everyone will notice. You think? Scientists caught MN45 using early data from an observatory on a mountaintop in Chile with a 3,200 megapixel camera. Ooh. It will be scanning huge areas again and again for 10 years to catch what moves, what flashes, and what wasn't there yesterday. The SuperCam takes an image every 40 seconds, and that's how it noticed MN45. The same equipment recently caught around 2,000 other asteroids, but our hero definitely stands out. Now, an asteroid spinning this fast probably didn't start life as a calm, normal space rock. Scientists think a past collision could have smacked it hard enough to spin it up like a toy top. And if that impact was violent enough, MN45 might not even be the original asteroid, but a fragment that broke off from a much larger parent object, basically a piece of a bigger monster that got shattered long ago. Spinning fast in space isn't just a flex, it's dangerous, because rotation creates stress, and stress tries to rip an asteroid apart. If a space rock doesn't have enough internal strength, it doesn't stay one object. It fragments into smaller pieces like a cookie that cracks when you twist it too hard. That's why most asteroids never spin this fast. Most of them aren't solid boulders. They're rubble piles, basically space gravel held together by weak gravity, like a floating clump of broken rocks. Astronomers have a kind of speed limit for asteroids. In the main asteroid belt between Mars and Jupiter, a typical rubble pile asteroid needs to rotate more slowly than about 2.2 hours per full spin to stay intact. Anything faster than that starts entering the danger zone. So if an asteroid spins faster than this limit, and it's still big, that's a massive clue. It must have unusually strong material inside, like solid rock or something even denser. Because if it were weak and crumbly like most asteroids, it wouldn't be spinning. It would already be a cloud of debris. The good news is that this hard rock asteroid isn't coming for Earth. It's at a safe distance from us, up in the asteroid belt. But its existence screams something terrifying. If something this big and this extreme stayed unnoticed until now, what else could be hiding out there? Perhaps the real threat isn't one record-breaking spinner, but a blind spot. Some simulations show that there could be a whole swarm of hidden city-killer asteroids hanging around Venus like cosmic pickpockets. As you can guess from the name, these asteroids are large enough to destroy an entire city. The reason they're so hard to catch is that they hide in sunlight. From Earth, the area close to the Sun looks bright and washed out, which makes it easy for objects near Venus's orbit to blend into the glare. It's like trying to spot a black cat in a dark room when someone shines a flashlight straight into your eyes. And this is where it gets personal, because humans love pretending we control space. But these Venus-hiding asteroids don't care. Their orbits can shift slowly over time because of gravity nudges and long-term motion. And that means one of them could eventually get pushed onto an Earth-crossing path. Not today, not tomorrow, but someday. And in asteroid terms, someday always arrives faster than people expect. Now let's talk about a completely different kind of dangerous asteroid, Bennu. Now Bennu isn't a solid rock freak like MN45. Bennu is a rubble pile, a loose, clumpy near-Earth asteroid about 1,600 feet wide. It's famous because NASA actually went there. The OSIRIS-REx mission grabbed samples and brought them back to Earth. And what scientists found inside was straight-up mind-blowing. There were life-linked elements, including sugars like ribose and glucose, plus a weird gum-like organic material, and even ancient stardust. Down on Earth, ribose helps build RNA, and deoxyribose helps build DNA. DNA and RNA are basically life's instruction manuals. They store information the way a hard drive stores files. But before you get too excited, no, finding these sugars on Bennu doesn't mean it had life. But it does mean the building blocks needed to build biology weren't rare or special. They were everywhere, floating around in the early solar system. Scientists have already found ribose before in 2 meteorites that landed on Earth, so it's not totally unusual. All that is cool and totally benign, but Bennu has a scary side too. It isn't likely to hit Earth, but researchers still model it because it has a very small chance of impact in the late 2100s, including around 2182. And if Bennu hit, it wouldn't wipe out dinosaurs again, but it could wreck climate patterns, blast huge regions, and trigger global-level effects, depending on where it struck. Bennu is like the perfect reminder that space can carry both the ingredients of life and the power to erase it. And if you want more reminders like this, space is like a gallery of cool asteroids. Take Ceres, for example, which was first classified as a planet, then demoted to an asteroid, and then promoted to a dwarf planet again. Hey, talk about an identity crisis. One thing is for sure, it's basically the boss of the main asteroid belt between Mars and Jupiter. No matter what label you slap on it, Ceres is a cold ball of rock and ice about 600 miles wide. Living there would feel like surviving on hard mode. Ceres has no substantial atmosphere, so you need a spacesuit just to breathe and to avoid freezing. Daytime temperatures range from about -136 to -28 degrees Fahrenheit, and at night it drops to around -225. But you'd also feel ridiculously light, because Ceres' gravity is only about 3% of Earth's. A 150-pound person would feel like 4.5 pounds there. Ceres is like a failed planet, leftover rubble from the solar system forming, a proto-planet that never fully grew up. NASA's Dawn spacecraft went to see it in 2015 and spotted bright white patches that looked like headlights from some strange spaceships. The biggest one sat inside a massive crater. Scientists thought it might be exposed ice, but it turned out to be sodium carbonate, salty mineral leftovers from briny water that bubbled up and vanished into space. Even crazier, that salty water may still come from a reservoir about 25 miles below the surface, and the activity could still be happening today. Life seems unlikely there, but with water involved, it might have existed in the past. Now this guy, Tututus, another cool asteroid, has a weird double-lobed dumbbell shape. Instead of smooth spinning, it does this chaotic tumbling motion, like someone tossed a wrench into space and it never stopped flipping over. Scientists think part of the reason for this weird movement is that Tututus might be two bodies barely touching. That makes it unstable right away. Then gravity shows up and makes it worse. As Tututus travels through the solar system, the gravitational pull of Earth and even Jupiter can tug on it, messing with its rotation like invisible hands turning it at random. That's what makes it so unpredictable. It's not just spinning, but constantly getting nudged into new motion patterns. The path it takes through space brings it close to Earth, which sounds terrifying, but the even scarier part is the word chaotic. Scientists determine its orbit for the next few centuries, and it won't collide with Earth in the next 6 centuries. But we don't know what can happen after that. So, as you can see, we don't need to be afraid of every asteroid scientists have spotted, but we might have a good reason to fear the ones they haven't seen yet. So, how do you feel about cooking? Nah, pasta and burgers are overrated. How about something more exotic, or rather, more cosmic? So, the recipe is simple. Take a team of enthusiastic astronomers and add some old images from the James Webb Space Telescope. Stir really well, and you'll get a shocking number of tiny asteroids in the asteroid belt between Mars and Jupiter. Yummy! The highlight of this dish is the direction in which some of the asteroids are moving, because in their way, there's our poor planet. Are we doomed just because you decided to cook? Now, the asteroids I'm talking about are much smaller than the massive space rock that wiped out the dinosaurs, but they can still cause considerable damage. They range in size from as small as a bus to as big as a stadium. But even those small ones pack quite a punch. Let's look at a recent dramatic example. It happened on February 15, 2013. A small asteroid just tens of feet wide exploded in an airburst over Chelyabinsk in Siberia, releasing an insane amount of energy. Many people witnessed and recorded the event, and it gave scientists vital clues. New computer models help scientists reconstruct the size, speed, and impact of the Chelyabinsk meteor. It was likely an asteroid, about the size of a 5-story building, exploding from 15 to 18 miles above Earth's surface with an enormous, incomparable force. The blast shattered 1 million windows and hurt over 1,000 people. Fortunately, it wasn't powerful enough to cause too much damage, but it gave us an idea about how dangerous an airburst can be. Now, an airburst occurs when an object explodes high in the atmosphere, never striking the ground, but releasing enough energy to devastate the area. But back to the small asteroids. The most dangerous thing about them is that they hit the Earth far more often than the larger ones, about 10,000 times more frequently. To make matters worse, their small size makes them harder to detect in advance, leaving little time for preparation if one is heading towards Earth. Now, let's travel back in time. Uh-oh, dinosaurs, too far back. Ah, there we go. A team of astronomers is working on a special method to find small asteroids in telescope images that were originally taken to study distant stars. Using this method, they've looked through thousands of JWST images of a star system called TRAPPIST-1. It's located 40 light-years away and is one of the most studied systems outside our solar system. Now, while analyzing these images, they discovered 138 new asteroids in the main asteroid belt, plus 8 they already knew about. And guess what? Among the newly found asteroids, 6 seem to have been pushed into paths that could bring them closer to Earth. Who did it? Well, probably nearby planets. Are they holding a grudge against Earth? Interestingly, scientists thought they'd find just a few new asteroids, but the number was much higher than they expected. Yet, it's no wonder. Right now, they're exploring a part of space they didn't know much about before. Now, let's talk about the hero of the day, the James Webb Space Telescope. It's especially good at finding small asteroids because it can detect their heat. These asteroids give off infrared radiation, which is much easier to see than the faint sunlight that reflects off their surfaces. This technology allowed scientists to spot the smallest asteroids ever seen in the main asteroid belt. The asteroids they found are pieces left over from collisions between bigger space rocks. Finding them helps astronomers understand the history of the asteroid belt and improve methods for tracking small asteroids that could threaten Earth. The researchers are planning to use James Webb to observe other star systems for at least 500 hours. They expect this work to uncover thousands more small asteroids in the solar system. Other advanced telescopes, like the Vera C. Rubin Observatory in Chile, will also help. Starting in 2025, this observatory will use the world's largest digital camera to photograph the southern sky every night for at least 10 years. Each image will cover a huge area of the sky, about 40 times the size of the full moon. The observatory might find up to 2.5 million asteroids in just 6 months, almost doubling the number we know about. Recently, NASA has identified 2 small asteroids. They were supposed to pass near Earth on December 16, 2024. Luckily, neither posed any danger to our planet. The first asteroid was 71 feet wide, about the size of a large airplane, and was traveling at 10,800 miles per hour. The second asteroid was slightly smaller, 56 feet wide, but it traveled faster at 14,700 miles per hour. But hey, even though this time the danger is past, who knows what the future will bring? It may sound weird these days, but astronomers didn't really care much about small asteroids for a rather long time. They thought of them as just random space debris that got in the way of observing stars. Some even called them sky parasites. But now, the way we see these little space rocks has completely changed. You see, until recently, we could only spot really big asteroids, those over a mile wide. The smaller ones just blended into the background noise in telescope images. But then, a clever trick appeared where multiple images of the same part of the sky were combined, making those faint small objects finally stand out. The data from certain telescopes, along with the James Webb Space Telescope, helps us improve planetary defense. But there's more to it than just protecting our planet. Studying these small asteroids also teaches us about how the solar system evolved. There are so many of them because they're fragments from collisions between bigger space rocks. One researcher has said this is like looking at old data in a new way. These small asteroids, which people used to think of as space junk, are crucial for understanding our solar system and even preparing for whatever the future holds. Among those hundreds of millions of rocks orbiting the Sun in the asteroid belt between Mars and Jupiter, some are especially worrisome. They come close enough to Earth for it to be quite concerning. NASA classifies asteroids that orbit within 30 million miles of our planet as near-Earth objects, and those could pose a serious threat if they were to collide with our planet. Right now, NASA is closely monitoring an asteroid named Bennu. This is a fairly large space rock, measuring about 1,600 feet across. It could, potentially, crash into Earth in 159 years. First, the astronauts spotted it in 1999. So currently, experts believe that there's a small chance Bennu could drift into Earth's orbit and collide with our planet by September 24, 2182. Would it be bad? Well, to put it in perspective, Bennu is taller than the Empire State Building. If it hit Earth, it would generate 1,200 megatons of energy, an amount so massive that nothing on Earth could generate that. NASA scientists are particularly concerned about a tiny chance that Bennu could pass through a gravitational keyhole during a flyby in the 22nd century. This keyhole is a region in space that could set the asteroid on a path that brings it directly to Earth. Now, Bennu flies by Earth every 6 years and has had 3 close encounters with us in 1999, 2005, and 2011. Right now, scientists estimate that the chance of Bennu hitting Earth by 2182 is about 1 in 2,700, more than 5 times greater than the chance of being struck by lightning. Although the chances of Bennu colliding with Earth are very low right now, this space rock is still classified as a potentially hazardous asteroid because it might come as close as 4.65 million miles to Earth. Now, this asteroid is another space rock that we need to keep an eye on. It's a near-Earth object about 1,100 feet across, and it was discovered in 2004. Initially, it was considered one of the most dangerous asteroids ever detected. Apophis quickly gained attention because experts believed it could pose a serious threat to Earth because of its close approach to our planet in 2029. However, after further study of its orbit, astronomers determined that there was no risk of a collision for at least a century. Well, we can all breathe easier now, can't we?
Asteroids aren't as rare on our planet as we may think. About 17,000 of them visit us every year. You've probably seen at least one in your life. For example, if you've seen a shooting star. They leave these bright tails behind them as they pass through Earth's atmosphere. Of course, they only look beautiful in the sky. If they reach the ground, the consequences would be catastrophic. Luckily for us, most of them explode 30 to 50 miles above the surface. Their mass is too small for them to withstand such a journey to the end, so most of them remain harmless to us. But we shouldn't underestimate them. Let's start with the smallest ones. 1 to 3 foot high asteroids are about the size of a person. They're too small to cause any real damage. Most often they explode in the atmosphere without even reaching its lower layers. But at the same time, they splash up tons of energy over the surface every time. 13 to 15 foot asteroids, the height of giraffes and mammoths. These larger meteorites come to us less often, once a year and a half. Like the previous ones, they, fortunately, don't pose a serious threat, but they splash out much more energy. 30 feet, the height of a 3 to 4 story building. They visit us once every 10 years, and now we're talking seriously. It throws out a wave that could demolish an entire city. I think you understand how catastrophic the consequences would be if this asteroid touched Earth. 65 feet, multi-story building. They like to visit Earth once every 60 to 70 years. Good news, it explodes at 12 miles above the ground. Its released energy could destroy an entire region if it touched the ground. Bad news, such an asteroid has already visited us recently, and the consequences were pretty rough. It all happened in a city called Chelyabinsk. On February 15, 2013, at about 9:20 a.m. local time, the giant slowed down in the Earth's atmosphere and then broke up into small pieces at 14.5 miles above the Earth. These pieces then flew in different directions. It shattered the windows all over the city and damaged many buildings, including people's houses, schools, and others. It took a while to repair everything, and the scale of this destruction was quite serious. As a result, there were 1,615 injured. But fortunately, no casualties. At least we're safe for the time being. The next such asteroid may come to us only in the 2070s or 80s, and no one knows where exactly it wants to land. Now let's move on. 300 feet. This is the height of the Statue of Liberty together with the pedestal. Such a giant can be seen every 4,500 years, and this is the first asteroid on our list that may literally crash into Earth. The consequences are disastrous. Not only may it demolish an entire city, but it can also set fire to neighboring areas. Well, some people even witnessed such a meteorite land on our planet. The notorious Tunguska meteorite is the biggest asteroid disaster that people have ever seen. It all happened on June 30th, 1908 in eastern Siberia. The meteorite was bright, like a second sun, and people felt the heat wave when it just approached the Earth. It exploded near the river. Fortunately, the whole area was surrounded by taiga, and there were no big cities nearby. But even there, it immediately destroyed a lot of trees. Serious forest fires broke out. The sound of the explosion was heard by people hundreds of miles around. At tens of miles around, all the houses' windows broke. The magnetic storm that resulted from this collision lasted 5 hours. The consequences were truly disastrous, but perhaps this is not the worst thing that awaits humankind. 99942 Apophis, 1,215 feet. It's slightly bigger than the Eiffel Tower. This meteorite, as scientists discovered in 2013, will be our next guest. Collisions of such force occur in about 100,000 years, and this one is gradually approaching. The force of such an explosion is equal to the force of the catastrophic eruption of the Krakatoa volcano in 1883. This eruption is considered one of the most destructive in history. It caused a terrible tsunami. 165 cities and settlements were completely destroyed, and another 132 were seriously damaged. People all around the globe could feel the consequences of this eruption, at least to some degree. Such an asteroid could leave a 3.5-mile crater, and this is one we'll face in the distant future. But calm down, no need to panic yet. By 2070, the meteorite will be almost 174 million miles away from us. It still has a very long journey ahead of it, so we're safe for at least 100 years, or even more. Besides, our planet has survived something even worse. 3,280 feet. This is higher than the tallest tower in the world, the Dubai Burj Khalifa Tower. Such collisions occur once every 500,000 years. We're not sure when such a collision occurred the last time. 70% of our planet is covered with water. If such meteorites fell into the ocean, it would be extremely difficult to find their traces. But we can assume the possible consequences. The wave would have swept across the entire hemisphere. The crater would be about 9 miles in diameter, and that would be a complete disaster. The last event of such a force happened 26 to 28 million years ago. It was an eruption of the supervolcano La Garita, which is located in the southwest of Colorado, USA. It was one of the most powerful known supervolcanic phenomena in history. During this monstrous eruption, a significant part of the current state of Colorado was destroyed. Scientists are still not sure how far the ashes have spread, but there was an even bigger meteorite in the history of mankind. The consequences of that impact were irreversible for an entire species of animals. I think you know what I'm talking about. Chicxulub meteorite, the thing that wiped the dinosaurs off the face of the Earth. This happened about 66 million years ago. These collisions in general happen about every 500 million years. The height of the Chicxulub meteorite was 12.4 miles. It's so high that when it touched the ground, it could reach the stratosphere. Even looking at the 124-mile diameter crater left by this meteorite, you can understand how huge it was. When it collided with the Earth, millions of tons of energy were released. This is an unimaginable disaster. It fell at a very steep angle, creating a giant cloud of dust and chemicals that spread around the world. This dust had a very thin layer, but also a mass of 50 trillion tons. The shockwave swept across the entire planet, It caused several earthquakes. Volcanoes began to erupt actively. Forest fires broke out everywhere, all over the world. The amount of soot and carbon dioxide released into the atmosphere is invaluable. The Earth was closed from the sun for several days. Darkness reigned all over the planet. Planets couldn't produce enough oxygen, so there was nothing to breathe. The temperature on the continents and in the oceans dropped by an average of 50 to 90 degrees Fahrenheit. Sounds horrific, doesn't it? And, of course, it caused one of the greatest extinctions in the history of the Earth's biosphere. Amazingly, the Earth was able to recover after such a catastrophe. This event became the boundary between the Mesozoic and the Cenozoic eras. So now, those who wondered, how could a small meteorite destroy all the dinosaurs, probably understand the answer. Perhaps the largest collision in the history of our entire planet was not a collision with a meteorite, but with an entire planet. This happened many, many billions of years ago. Theia, as this hypothetical dwarf planet was called, crashed into our Earth, releasing an incommensurable amount of energy, just quadrillions of fuel. The Earth then instantly turned into a giant fire, and it was this collision that led to the creation of the Moon. All that sounds terrifying, I know, so let's just hope that you and I will never see anything like this.
A huge asteroid, several hundred feet across, is dashing towards Earth through the black nothingness of the cosmos. Ooh. Brace for the terrible news. There's a 72% chance it might hit Earth in 14 years, with potential impact zones being North America, Southern Europe, and North Africa, some of the most densely populated areas on the planet. Astronomers have been keeping a close eye on the space invader for a few months, but now it's moved too close to the Sun, and tracking it is impossible for the next 7 months. Of course, there's a 28% chance that it will miss our planet altogether. But what if it doesn't? Global devastation and destruction, that's what. Thousands of lives lost, billions and billions of dollars in damage, entire species wiped off the face of the Earth, ruined cities and towns, destroyed fields and forests. We're left wondering whether it's the future awaiting for us. Well, now you can breathe easy. That's just a hypothetical scenario created by NASA to prepare for a situation like this. The space agency has been thinking about this kind of disaster for years. Even cooler, they run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. The last one occurred in April. Over 100 people took part in that event. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it? Where might it hit? What should we do? It's like a massive brainstorming session to make sure that if it ever happens, we won't have to start from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life. Now, if an astronaut really was aiming at Earth, it wouldn't be just one country's problem. It would be everyone's. That's why this exercise brings in international experts. In April, it happened for the first time. They worked alongside U.S. agencies like NASA's Planetary Defense Coordination Office and FEMA to understand how the world might respond to such a crisis, since an asteroid impact would have dire consequences globally. Now, the big question is, can we actually stop an asteroid from hitting Earth? Here, there are two main options experts consider. First, we could send a spacecraft to gather more info. If we knew more about the asteroid's size, mass, and orbit, we'd be able to make better decisions about what to do next. The second option is to try to deflect it. Basically, it means bumping the asteroid off its course so that it misses Earth. This might sound impossible, but NASA's DART mission has already proven that we can do it. 2 years ago, they crashed a spacecraft into a small asteroid called Dimorphos and successfully changed its orbit. It was a huge victory for planetary defense. But missions like that take tons of time to plan, prepare, and carry out. That's why spotting dangerous asteroids as early as possible is so important. Currently, NASA is working on a new telescope called NEO Surveyor which is set to launch in 2027. Unlike good old telescopes, NEO Surveyor is designed to detect even the trickiest asteroids, including ones orbiting close to the Sun. It'll give us a better chance to act early and potentially stop an asteroid before it becomes a threat. If you still think that an asteroid impact is something out of science fiction and the threat isn't real, how about this? Early on Sunday, January 21st, a small asteroid about 3 feet wide entered Earth's atmosphere and luckily burned up over Germany. NASA's Scout Impact System spotted it 95 minutes before it hit and predicted exactly when and where it would arrive. At 1:32 a.m. local time, the asteroid turned into a blazing bright fireball, visible as far away as the Czech Republic. Some small meteorites might have landed near the impact site, about 37 miles west of Berlin. This is just the 8th time ever that an asteroid has been detected before it hit Earth. It's a splendid example of how tools like Scout are helping us track asteroids and prepare for anything bigger that might come our way. Here's another example. A small asteroid turned the skies over northeastern Siberia into a breathtaking light show on December the 4th, burning up harmlessly in Earth's atmosphere. The space rock, about 28 inches across, was spotted just hours before it hit. Thanks to observations from astronomers around the world, a special alert system managed to predict the impact to plus or minus 10 seconds. The asteroid entered Earth's atmosphere at 1:15 a.m. local time. The authorities were put on alert, but there was no damage reports. NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted the rock 12 hours before it entered the atmosphere. This makes it the 4th imminent impactor, which is an asteroid discovered within hours of its expected impact, detected this year, and the 11th overall. Now, China also has big plans for planetary defense. They're working on their first mission to hit an asteroid, and it's got a double purpose. One spacecraft will crash into the asteroid, and the other will hang back to study the whole thing for up to a year. In other words, it's not just about protecting Earth, it's also a way to learn more about the solar system. The target is an asteroid called 2015 XF261, which is a mouthful, and also about 100 feet wide. It flew by Earth recently on July 9th, passing us at 31 million miles. True, it's pretty far away, but the space traveler was zooming by at a speed of 26,000 miles per hour, 30 times faster than the speed of sound. China is going to send a space probe to study the asteroid. They're hoping to learn more about its structure and composition, which could help us with future planetary defense missions. Then they plan to hit the asteroid with another spacecraft to test the impact, and the first space probe will stay there to observe the remains for up to a year. Timing is critical for this mission, and the asteroid offers some good opportunities in the next few years. Thus, in March and May of 2027, the asteroid will pass within 20 million miles of Earth. In April 2028, it'll get even closer. By that I mean 13 million miles away. A year later, in April 2029, the asteroid will end up just 4.2 million miles away, making it the best shot for a mission. Another decent chance will be April 2030. That's when the asteroid will pass our planet at 4.4 million miles. To give you some context, NASA's DART mission once targeted an asteroid 7 million miles away, and the trip took 10 months. So China's planners have to pick the right moment, depending on how long their spacecraft will need to get there. The mission is expected to start around 2027. At the same time, this won't be China's first attempt to target an asteroid. Back in 2023, they were planning a planetary defense test with a different asteroid, which is also about 100 feet wide. It's not clear why they switched to the current one, probably because the timing works better. Most asteroids are basically time capsules from 4.6 billion years ago, leftovers from when the solar system was just forming. Studying them could tell us a lot about how planets, including Earth, came to be. So, China's taking on something that combines planetary defense and pure space science. They're definitely making big moves in the space exploration game. So, theoretically, humans can survive an asteroid that has the potential to destroy entire planets. It won't be a walk in the park, though. Let's go back in time to 66 million years ago, in the late Cretaceous period, the Earth, before humans, where dinosaurs are thriving. The plants and animals are rich and diverse. You'd see a T-Rex chasing a Triceratops, or the massive Alamosaurus, one of the biggest animals to ever roam the planet, towering over the landscape. In Texas, they remember the Alamosaurus. And watch out for the Ankylosaurus, a living tank swinging its tail like a wrecking ball at any threat. As you're about to enjoy a quiet evening under the stars, a bright new light appears in the sky of the northern hemisphere. Now, a new star in the sky doesn't really stand out at first, it's just twinkling like the rest. But give it a few hours and you'll notice it's getting brighter. Check again the next night and boom, it's the brightest thing in the sky, outshining planets and even the moon. And finally, it horrifyingly outshines the sun. The star was the Chicxulub asteroid, which left a gigantic crater now called Chicxulub Crater in Mexico's Yucatan Peninsula. The asteroid enters the Earth's atmosphere at a blistering 12.5 miles per second. It blasts through 60 miles of the atmosphere in about 3 seconds. It falls so fast that even the air can't get out of its way. The air gets squashed and heats up to thousands of degrees in a blink. Before the asteroid even touches the ground, this super hot air has already vaporized much of the sea where it's about to strike, near the Yucatan Peninsula. Then, in a flash, the asteroid smashes into the Earth, screaming over Central America with a loud boom that echoes everywhere. It doesn't just smash the ground, it makes the soil and rock flow like liquid. The asteroid digs a hole so wide and deep that it nearly touches Earth's inner layers and throws up dirt more than 20 miles high. At that exact moment of impact, the asteroid also turns its massive speed and weight into heat in a split second. It puts so much energy into the Earth that it makes molecules move faster than the surface of the Sun. This massive energy created a giant ball of plasma, superhot charged gas that includes bits of vaporized rock. This all shot out at incredible speeds. The shockwave from the impact and the heat turned the Earth around the crash site into gas instantly. This set off earthquakes all around the world. And it's not just the rocks flying around that you need to worry about. As they plummet through the sky, they rub against the air, heating up so much that they set fires all around the world. The heat they give off could be compared to an oven cranked up to its highest setting. This fiery shower causes most of the world's trees to burn down. The entire world is now on fire. Soon it changes everything. In a blink, dinosaurs were wiped out, making way for mammals to rise. And not only dinosaurs, 75% of species and big creatures disappeared, leaving behind only some small birds and critters. So, how could you, a human, survive something like that? Now, some animals made it back then. To survive, we need to learn from their resilience. The only birds that survive even in the toughest conditions are the ones nesting safely on the ground. Among the few larger animals that manage to dodge extinction, all have ways to deal with the heat. Some, like certain small mammals, snakes, and lizards, can dig themselves into cooler underground burrows. Others, like crocodiles and turtles, just hide in the water. So, if you're exactly on the other side of the planet when the strike happens, and you act super fast, you might just make it. Right now, the impact is about 10,000 miles away, but don't underestimate its power. As soon as you hear the loud boom, head underground as quickly as you can. And be careful, because you'll feel the earth shake about 30 minutes later. Hide in a deep cave, preferably with a narrow entrance. It would protect you from the falling debris, and the temperatures underground would be stable. Also, some caves have natural water sources, rivers, or streams. You might also prepare for the not-so-great diet of insects, fungi, or poor small animals that also seek refuge in the cave system. But it's better than nothing. You also need to be extremely far away from any large bodies of water. Being near the ocean might seem like a safe bet during a massive asteroid impact because the sea can buffer extreme temperature changes. But the earthquakes trigger terrifying tsunamis, even in lakes or fjords. The asteroid's crash sets off not just one tsunami, but many, and they're as tall as skyscrapers. Within an hour, colossal waves between 600 and 1,000 feet high hit the Gulf Coast, slamming into places like Mexico and the southern United States, and flooding miles inland. These waves are so powerful, they even push rivers backward. These tsunamis continue around coastlines, reaching the east coast of the United States, and 6 hours later, they hit Europe, Africa, and the Mediterranean. By 15 hours after the impact, there isn't a coastline on Earth that hasn't felt the wrath of these waves. Well, let's say you survived the initial impact somewhere deep underground, but your troubles have only begun. The Chicxulub asteroid strikes a region loaded with sulfur. This sends 100 billion tons of sulfur and an enormous amount of water into the sky. The water vapor forms massive storm clouds. They start to rain acid. In colder places, huge snowstorms bury the land under feet of snow each day. The impact also vaporizes massive amounts of oil, throwing up 150 football stadiums worth of it into the air. This oil turns into a thick black soot in the stratosphere. It coats the Earth like black paint. And even when the acid rain calms down, this carbon stays up above the clouds and doesn't wash away. This sooty layer blocks out 90% of sunlight, plunging the Earth into a cold darkness that lasts for at least 3 years. The world cools down by about 50 degrees on average. Now, when you finally leave your deep cave, you must look for places where you won't freeze. The only spots spared from the frost are tropical islands like Madagascar, India, which was an island back then, and Indonesia. These places have surviving plants and animals, and they even continue to get fresh water, unlike most of the world. Everything else in the world looks like a huge nuclear wasteland. These tropical islands are safe spots during an asteroid apocalypse, but don't think of them as paradise. These places still only get about 10% of their usual sunlight and barely enough rain to avoid turning into deserts. In this chilly, gloomy setting, most food chains fall apart. If you want to survive, you'll need to bring lots of extra food with you, for the next 6 years at least. Now, some things are lucky enough to survive. Fossils tell us that freshwater ecosystems did well, so staying close to a river or estuary might be your best shot at finding food. You could come across turtles, crocodiles, and some fish. Animals like clams, snails, and small crustaceans that live in the sediment also manage to hang on. And while a bit warmer than everything else, these places are no walk in the park. You'd need to pack warm clothes to have any chance of survival. Now, if we add all this together, the best spot for surviving the Chicxulub asteroid would be Indonesia. It's a mountainous, tropical country that consists of several islands. There, you'll find bearable temperatures, a bit of rainwater, and a deep cave for shelter. This could protect you from the falling tektites, the intense heat, and even help you find something to eat in the rivers and lakes. But if you stumble upon any shrew-like creatures while scavenging for food, time traveler, please let them be. It's not clear how many survived the Chicxulub impact, and eating one could have unforeseen effects on the future of humanity. Like, don't eat your great-great-great-great-great-great-grandfather, right? You look up and see a bright orange flash in the sky. A bit later, you hear a boom so loud the window panes around you burst into pieces. And then you see it. A giant piece of space rock burning high above your head, heading for Earth. When it touches the surface, the explosion leaves behind an enormous crater. It's 12 miles deep and as wide as Lake Michigan. After that, 3/4 of all living organisms on our planet are on the edge of survival. This event took place about 66 million years ago, and the bright flash in the sky was the very asteroid that wiped out the dinosaurs. These days, people have many ways to protect themselves, like we could hide in bunkers deep underground and survive. Such bunkers would already come in handy, since there are many asteroids in the sky, and some of them are just waiting for their ticket to Earth to wreak some havoc. For example, the asteroid 1990 MU. In 2027, it'll come alarmingly close to our planet. Many people fear that Earth's gravitational pull will trap the rock, which is the size of 2 Brooklyn bridges. In this case, it'll start to move closer and eventually crash into the planet's surface. Such an impact would cause a shock wave that would be felt on other continents. Once the asteroid hit the ground, there would be an explosion. It'd be so bright, people would think a new sun appeared right here on Earth. The collision would release a huge amount of energy that would then turn into heat. Everything around the impact site would catch fire. And if the asteroid fell in the water, It would cause tsunami waves higher than the Empire State Building. Many coastal cities would be flooded. The dust that would rise after the explosion would cover the sun. The world would be plunged into darkness. If the dust stayed in the air long enough, the climate on the planet would change and Earth would start to freeze. If you think such a small meteorite can't cause serious damage, look at the Chelyabinsk meteor. It hit the Earth in the winter of 2013. When the space rock entered the atmosphere, people miles away heard a loud bang. The brightly burning object was approaching the surface at about 11 miles per second. Halfway through the flight, it split into several pieces. This caused several stronger shock waves. When the meteorites hit the ground, it caused a major earthquake, and the aftershock from the explosions shattered the windows of 5,000 buildings. People in 6 cities around the crash site felt the aftereffects of the fall, and this meteorite was only 60 feet wide. Fortunately, the asteroid 1990 MU will move past our planet. We'll be safe. Whew! But the next asteroid to approach Earth is going to be 3 miles wide. It's called 3122 Florence. If this giant hit our planet, it could wipe entire continents off the face of the Earth. In 2017, this space rock got awfully close to us. It could be seen in the sky even with a small telescope. Now, the next asteroid is the biggest one to worry about, 1999 JM8. It's about as wide as Manhattan, and it has an unnerving habit of approaching Earth a bit too close for everyone's liking. A small asteroid named 2020 VT4 got closer to our planet than all others have ever done. In November 2020, it flew over the Pacific Ocean at an altitude a bit smaller than the distance from Los Angeles to Las Vegas. That space rock was about the size of a big car. If it did make it to Earth's atmosphere, it would burn up completely before touching the ground. Falling asteroids and meteorites aren't uncommon on our planet. Luckily, most of them burst into flames and burn up before they enter the atmosphere. Mars is to blame for such frequent meteor showers. The planet isn't far from the main asteroid belt in the solar system. Sometimes, the gravitational pull of the red planet grabs asteroids from there. Then, Mars spins them around and flings them in our direction, just like a slingshot. So, Mars is a bully. Good thing we're protected by Jupiter. It's the largest planet in our solar system, and it has an incredibly strong gravitational field. It keeps the asteroid belt in line and protects us from being constantly hit by a rain of meteorites. And that's good news, considering Ceres is in the asteroid belt. This enormous space rock is so big that it was once considered to be a planet. Then, for many years, scientists called Ceres an asteroid. But in 2006, it was finally classified as a dwarf planet. This space object contains a third of the total mass of the asteroid belt, which is about 4% of the Moon's mass. If Earth were as large as a nickel, Ceres would be about the size of a poppy seed. So, what if an asteroid several miles across was heading toward our planet and people had to stop it? Well, we could break the space rock into smaller pieces. A massive explosion could be used to do this. People wouldn't even need to land on the giant asteroid. Getting close to its surface would be enough. Boom! A powerful burst of energy would split the asteroid into several large pieces and tons of debris. The smallest rocks would burn in the heat released in the blast, and it would also change the asteroid's trajectory. The larger fragments would burn up while entering the atmosphere. All witnesses of this unusual meteor shower would have a chance to admire a beautiful fire show. Another means of protection could be a kinetic battering ram. Simply put, it would be a huge object that people would send towards the asteroid approaching Earth. Or it could be a heavy spaceship. This is the method scientists produced to prevent the asteroid Apophis from falling to Earth. This guy is 1,200 feet across and often passes by our planet, coming as close as 19,000 miles above Earth's surface. The asteroid is going to pass close to our planet again in 2029, and there is a possibility that in 3036 it might crash into the Earth. If it happened, the explosion would leave a crater more than 3 miles across. Within 6 miles of the impact zone, all buildings and subway tunnels would be crushed or severely damaged. The event would also trigger a powerful earthquake. In the area of 30 miles away from the crater, car windows and window panes in houses would be shattered. And 75 miles away from the impact site, the earthquake would move furniture and buildings. One way to stop such a catastrophe is to build a heavy spaceship. It would take off from Earth, speed up, and then ram into the asteroid with great force. This impact would alter the course of the huge space rock, and it would fly past our planet. We could also try to stop the asteroid by wrapping it in foil. This would make its surface reflective, and then solar pressure might gradually change the asteroid's trajectory. Another alternative is using the gravitational tug. In this case, we would send an unmanned spaceship, large and heavy, toward the asteroid. It would fly over the space rock and slowly draw the thing closer with its gravitational pull. A small change, of course, would be enough to make the asteroid fly past our planet. Another way to protect Earth would be to build a system of giant lenses in space. Perhaps you've tried focusing sunlight with eyeglass lenses. Then you know how hot this sunlight can get. Now imagine having many giant lenses that are all directed at one point. Scientists think that focusing such a powerful beam of light on the asteroid would make the rock melt and evaporate, slowly changing its route. And one more way to protect ourselves from the asteroid would be to install several rocket engines on its surface. It would turn the space object into a rocket, and we could set its course from Earth. Rogue stars pose a much bigger danger. Like asteroids, they fly through space and can collide with anything in their path. The problem is that they have a gigantic mass, sometimes comparable to our Sun's. Around 70,000 years ago, a duo of rogue stars whooshed past the Sun. It didn't affect Earth, but caused some disturbance on the outskirts of the solar system. This event is likely to happen again someday. The rogue star Gliese 710, about half the mass of our Sun, is moving toward our solar system right now. There's a possibility that it'll begin to grab asteroids from the outer asteroid belt and toss them at us. And then, rare meteor showers you can observe these days will become a regular occurrence. But right now, this rogue star is extremely far from our world, and there's a bigger chance that it'll pass by without affecting our peaceful existence. Tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the Sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub Impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub Impactor now holds first place among the brightest objects in the sky. The light surrounding it, called the halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub impactor is brighter than the full moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They in turn generate tsunami waves as high as the Empire State Building. 5 minutes after the impact. The meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface nonstop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon, they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ramp. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further this space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth. Hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the Sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the Sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the Sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it produced a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the Sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bang! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the Sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the Sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, Space bodies absorb most of the sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.